In today's lesson, we're covering the various components of an electrical system. This video is divided into 4 topics. Part 1, how to size your battery bank. Part 2, how to charge your batteries. Part 3, putting it all together, connections, wires, and fuses. And Part 4, system monitoring. Let's get right to it. The first step in designing a power system is to list all of the appliances, devices, and electronics you would like to use in your van. Lights, TVs, computers, vent fans, water pumps, the refrigerator, cooktop, water heater, and so on. As an example, here's a list of every powered device in my van. Your list may be shorter, or it may include items like a water heater or microwave that I do not need. The types of devices on your list play a big role in the design of your power system. In general, the more power-consuming devices you have, the more complex and costly your system becomes. Once you have a list of devices, estimate how often or how much time you plan to use them each day. The easiest way to estimate your power usage is to create a spreadsheet listing each item, the power used in watts, and the number of hours it is running per day. Set up a formula to calculate the number of amp hours for each item, and then total up amp hours. Remember that some items, like your refrigerator, do not run continuously, so you may want to research their power usage and estimate it. For example, let's consider a set of LED overhead lights. If those lights consume 2 watts of power each, supplied by a 12-volt battery bank, then they are drawing a total of 1 amp. Using the equation power divided by volts equals current in amps. If you leave those lights on all night, say 10 hours, then they will need 10 amp hours of battery capacity. A 100 amp hour battery will still be at 90% capacity by morning. More realistically, you'll probably only leave those lights on for a few hours. The refrigerator will cycle on and off throughout the day. You might watch TV for a couple of hours, charge up your phones, and cycle the water pump several times. All of that combined may use 50 amp hours in a day, and your 100 amp hour battery will still have plenty of capacity the next morning. Once you estimate the total amp hours you need per day, then you can size your battery bank accordingly. You simply want to have enough capacity to meet your daily needs and have a recharging system to keep up with those demands. When I was designing the power system for our van, I determined that I would need no more than 50 amp hours per day. I wanted to be able to go at least a couple of days without needing to recharge, and I didn't want to stress out about having a low battery. With that in mind, I chose to use 2 100 amp hour batteries and 3 charging methods. I also decided to use lithium batteries for their longer lifespan, lighter weight, and their ability to be drained to near 100% of the rated amp hour capacity. Next, I will discuss the different methods of charging your battery bank. Here are a few things you should consider when deciding how to charge your battery bank. How quickly you need to replenish the power you consumed, whether or not you'll be driving each day, the amount of available sunshine, and if you will have access to shore power. Part of this consideration will be your own personal preferences and lifestyle. We usually drive each day while traveling, and if we are parked for the day, it's often sunny. We rarely have access to shore power, so that side of the charging equation is negligible. If you have a large enough battery reserve, and you drive frequently, you may decide to skip a solar charging system altogether. Since I personally wanted charging flexibility, I installed 3 charging methods: solar, alternator, and shore power. Here's a simplified explanation of each system. For solar charging, I have 2 175 watt panels wired in series. Each panel is rated at 18 volts, which combines to 36 volts in full sunlight. This delivers at most around 10 amps to the solar charge controller. The charge controller's job is to regulate the voltage being sent to the batteries and supply the needed amperage. I can usually get at least 30 amp hours of solar power production on a sunny day. An added benefit of having solar is that most of the power used during the day is being produced by the panels, and the batteries are bypassed altogether. With my 200 amp hour battery bank and 50 amp hours per day usage, solar panels alone can maintain the system for about 10 days. My secondary charging system utilizes the van's alternator while driving. The alternator produces a substantial amount of power, and like solar panels, this power needs to be regulated to both protect the batteries and the alternator. I programmed the DC to DC charge controller to send a maximum of 15 amps to the battery bank at a regulated voltage. Doing the math gives us a charge production rate of 15 amp hours per hour of driving. This alone will fully replenish my daily consumption in just over 3 hours of driving. As I mentioned earlier, if your daily driving hours are enough to recharge your batteries, alternator charging may be all you need, especially if your battery bank is large enough to provide you with several days of capacity. The additional cost of a heavy-duty alternator and a large battery bank may be offset by not needing a solar charging system. Again, this comes down to your driving hours and lifestyle. Alternator charging needs to be carefully integrated into your van's electrical system. You will be increasing the wear on your alternator and will possibly decrease its lifespan. Use caution when making these connections or hire a pro to do the work. Installing a shore power system has several benefits and can be quite inexpensive. A basic setup starts with a shore power outlet, which you can mount to the exterior of your van. I use 10-3 Romex household wiring to distribute this power to 3 AC outlets inside the van. One is used for the shore power charger, one for the TV, and one for the refrigerator. The TV and refrigerator automatically switch over to AC power when I plug in. Charging your batteries with shore power can be done by wiring a battery charger to your system. The Victron charger I use can be remotely monitored and programmed to deliver up to 30 amps to your battery bank. Since this AC circuit is running off an extension cord, I am careful not to overload it. I use a 25-foot heavy-duty extension cord rated to 15 amps when connecting to an outdoor outlet. Be sure that everything you have plugged into these AC outlets at the same time draws less than the rated capacity of your extension cord and amperage of the AC circuit it is plugged into. Now that we've covered sizing your battery bank and the different options for charging, let's dive a little deeper into tying your system together. As you can see, power flows from your battery bank to your electronic devices and also flows from your charging sources back into your battery bank. Not only do you want this system to perform efficiently, you want it to be reliable and safe. Even a small battery bank can send thousands of amps through your system during a short circuit event. At the very least, this will damage your equipment and at worst, can start a fire. Once you understand how your system works and have studied basic electrical principles, you can take the proper measures to help ensure your system operates correctly. In this section, I will cover how to make good connections, how to properly size your wire and fuses, and how to take precautions to prevent short circuits and other system faults. Please note, however, I am not a licensed electrician and have no formal training in the field. I'm a physics teacher and a part-time van builder. It's important that you continue to do your own research and only take on what you feel comfortable doing. If you are in doubt, please consult a professional or consider having your electrical work done by the pros. When terminating wire, start with a clean cut using quality wire cutters. Strip the protective covering back only as far as needed according to the recommendation of the connector's manufacturer. Terminating stripped bare wire can be done by inserting it into a ferrule, lug, lever nut, spade, or directly into a device and clamp down. Use heat shrink tubing to cover bare wire and metal and to help strengthen the connection. Use the proper tools for the job, such as a ferrule or lug crimper, and always check for loose strands or wire. Be sure to match the connector to the wire size, and be sure to tighten all connections and give it a pull to make sure. Choosing a wire size or gauge is important because it is what limits the amount of current that can safely flow through the wire. Most wire you will use in your van will range from 4/0 wire used to connect batteries to 4 to 8 gauge wire used to connect your solar panels, DC chargers, and main circuits, to 12 to 14 gauge wire to connect most of your DC circuits, to as small as 22 gauge wire that may be attached to some of the low amperage devices like LED lights, hardwired alarms, or cameras. To determine the proper wire size, refer to a sizing chart such as this one from the National Electric Code, or always follow the manufacturer's recommendation. It's better to use a higher ampacity wire than needed than to use the minimum. If you add to an existing circuit in the future, the wire will be able to handle the increased load. If you want to take a deeper dive into wire sizing, you also need to consider the length of the run and how it relates to voltage drop and resistance. In general, keep your wire lengths as short as possible and plan your layout to reduce unnecessarily lengthy runs. This can affect where you place batteries relative to voltage-sensitive devices like your solar panels, chargers, and inverters. Fuses are used to protect wires in the event of a short circuit. To understand what happens during a short, start with the battery, the source of power. During a short circuit, a vast amount of current will instantly begin flowing into your system. This current may be many times the rated output of your battery, possibly thousands of amps. Any wire that cannot carry that current will heat up and can catch fire. There are several things you can do to prevent this. First, prevent wires from shorting in the first place. A wire will short circuit when the current carrying metal inside the sheathing touches grounded metal or another ground wire. This can occur, for example, when a positive wire rubs against a sharp edge and wears through its protective covering. Be sure you have added additional protection where this may happen. Use wire loom, rubber, plastic, or other protective materials as needed. Your best defense once a short occurs will be to have a properly sized fuse in place. Fuses protect wires and must be placed as close to the source of power as possible. Try to connect the fuse directly to the source's bus bar or within inches of batteries. Fuses must be sized properly to allow the needed current to flow while preventing excess current during a short. Each fuse must be sized according to your devices and power supply. Every time you go down in wire size, you need to add a fuse immediately following the wire size reduction. In my system, for example, this happens at the links distributor and again at the DC fuse panel. In my van, I used 200 amp fuses at the battery, 40 to 60 amp fuses inside the links distributor, and 10 to 25 amp fuses in the DC fuse panel. Each fuse size was determined either according to the device manufacturer's recommendations or by multiplying the device's continuous amperage by 1.2 and rounding to the nearest available fuse size. However, when rounding up, do not exceed 150% of the rated wire ampacity. Now that you have everything up and running, how do you monitor your system? If you have designed it correctly, your battery bank will be partially depleted each day and adequately charged as well. Ideally, you only need to monitor your system to reassure yourself that everything is working as designed. If you are like me, however, you will want to see every component's status and performance in real time, maybe even a history report or remote monitoring capability. a color display would be nice too. At the very least, you'll want a way to check on your battery's voltage. A simple voltmeter like this is all you need for basic monitoring and for less than $15. Fortunately, most battery chargers and controllers will display battery voltage, consumed current, and charging rates. The components I installed in my van have Bluetooth connectivity and can be monitored and programmed with an app on my phone. Being able to closely monitor your system gives you the peace of mind that everything is operating correctly. If you would like to learn more about van conversions, check out my videos on electrical systems, including installing solar-powered DC to DC chargers, shore power, and choosing the right wire size. If you would like to know how much we spent on our van, check out my video on how much our 2023 Ram Promaster cost to build. Also, check out the links in the description below for more information on any of the products mentioned in this video. And if you found this video helpful, hit that like button, subscribe for more content, and share your thoughts and experiences in the comments below.